Hello, Internet, and thank you very much for tuning into the Cloud Native Islamabad YouTube channel. And hope today everyone will be, we have some good audience today in our stream today because we are actually covering CKA exam updates and some insight as well. The CKA is basically Certified Kubernetes Administrator exam, and it has earned his reputation as one of the most challenging yet rewarding credential in the tech world. And it's not just a test of Kubernetes knowledge, it's a validation of hands-on skill that organization critically need these days. With Kubernetes at the heart of the modern cloud native architecture, the demand for the certified Kubernetes administrator has been seen skyrocketing as enterprises strive for efficiency, scalability, and reliability in their infrastructure. In this session, we will be exploring that what makes the CK so popular amongst professionals and why companies highly value CK certified talent. And most importantly, this exam is going to be making some changes coming up not before January 15th, 2025. And we will walk you through the latest changes to the exam, breaking down what's new, how it's impact your preparation, and tips to navigate these updates successfully. And without any further delay, I have the best guest with me, Chad Crowell. Chad, you're live. Over to you, and let us little bit about what's some recap of KubeCon at first, and then we jump into the CK exam.
Yeah, really happy to be here. Yeah, KubeCon last week was amazing as usual. Never disappoints. There were just as many people as last year. I always love meeting up with my cloud native friends and chatting about lots of different things. I did a book signing. I gave a few talks, and yeah, talking about the CKA exam mostly, and the changes coming up, which we'll get into. So very exciting.
Awesome, absolutely. And before we start again, I'll let people know who are really first time hitting this URL and joining us for the first time on this YouTube channel. Chad has a book, Acing the CK Exam, one of the very famous one in our cloud native landscape. And also it's give you some examples, some codes walkthrough, and everything you need to get prepared for the CK exam before scheduling and going into the exam and actually cracking the exam itself. Also, we have done two workshops on this YouTube channel. And if you're really new to it, I think these are the most famous one in our YouTube channel. CK hands-on workshop, part one, and we have two parts we already covered. So this is most exciting because we know there are some changes planned. Might be some good news for the folks, or might be the very bad news for the folks, considering the way you look at the exam update as well. So without any further delay, over to you, Chad. You can share your screen, and I will let people know if there are some glitches or anything, and we need to fix things up. So over to you now.
Yeah. So as you mentioned, there's kind of a part one to this. So this is part two. Part one is where we went through some exercises in the book, and I will share my screen and talk about that a little bit so that we can make a smooth transition from this part to the previous. First of all, if you're brand new to the exam, I just want to cover a few things. The exam is entirely hands-on. It's like no other exam that you've ever taken before. Very different than any other industry exam. In that you are given a terminal. You're given a number of tasks to complete inside the terminal, and then you're graded on your performance on those tasks. Are you able to create the proper pods and deployments? Are you able to correctly troubleshoot the services and the kubelet, for example? Those are the types of things that you'll be tested with on the exam. and you'll be performing kubectl, systemctl, cryctl, perhaps commands in order to solve those problems. So there is, it's a quite difficult in that sense, or you could view it as, this is kind of the what you would be doing in the real world, right? So it's very much related to a job as a Kubernetes administrator. So I happen to like the fact that it's entirely hands-on, and I happen to like this format because it's you're actually doing something as opposed to having to memorize a theory, or trying to think abstractly. You're actually performing the commands. You're getting hands on keyboard, and that's I think that's why that the exam is so valuable, and so valuable in the industry, and having it on your resume, I would say, is a good testament to actually being able to do the things that are required by a Kubernetes administrator, or a DevOps administrator, or a platform engineer, whatever you want to call it. These are, this is a true test, this exam. So the way that in which they do that, the way in which the CNCF does this, and the Linux Foundation, is they will provide you with what's called the PSI bridge. The PSI bridge is a RDP'd environment. So your remote desktop into a Linux desktop, or kind of a XFCE like, or a GNOME like desktop, much like you would have on your laptop if you're running Linux on your laptop or on your desktop. And you will have the ability to, along with the terminal, use the Mozilla Firefox that's included in that RDP environment. You can have one tab at a time open to the Kubernetes documentation, so docs.kubernetes.io, or you can have in that same tab a connection to, or you can have up the Kubernetes GitHub page. So github.com/Kubernetes/Kubernetes. So these are the only two pages that are allowed. It is in that sense, it's an open book test. However, you only have 2 hours to complete the entire thing, and this is 16 to 18 questions that in the form of tasks that you have to perform in the terminal again. And that there may be subtasks within that question, so it takes a long time, and I would say you're going to be pressed up against that 2-hour window. So don't rely too heavily on the documentation and or the GitHub page to provide you with help, and I certainly wouldn't be reading the documentation. Go into it knowing how to navigate the documentation, take advantage of the search function in the documentation, and also be able to quickly bring up those pages that you need, whether you're copying and pasting YAML, etc. So that's a little bit about the exam from a very high level. You can find more information about the exam if you just Google CKA exam, and you can go to the CNCF link. It's one of the top 5 links, it should be, and it just starts with cncf.io. So if you go to this link, you'll see, this is how you find out more information about the exam, join the training mailing list. And so if you scroll all the way down, it lists the domains, etc. So if you scroll all the way down to the exam resources, you'll see some important links that you can read more about the exam, including about the PSI bridge, which we just talked about. So for example, in the handbook lists the requirements for your exam environment. This exam you cannot take in a testing center, so you must take this exam at home or in your office. So this provides details, this exam handbook provides details on how to clear your desk, clear your environment, make sure that you're in an environment that's suitable for taking the exam according to those rules. A couple important, pages within this handbook are the frequently asked questions, CKA, CKD, and CKS. The reason why those exams are grouped together is because those are all in the same exam format. So in the same method that is entirely hands-on, entirely in the terminal. So those 3 exams are unique in that way. So frequently asked questions is a good page to kind of scroll down to. Important instructions, also important. And we'll tell you a little bit more about the system requirements, the important information to consider, etc. So I won't read through this because there's a lot of information here, but this is a good, handbook to get familiar with before the exam. Another important link is the curriculum overview. So this is going to tell you all of what's on the exam. So the CKA curriculum, if I click into it, it's just a GitHub repo, which contains the curriculum for all the different exams. So if you look at the CKA, as of right now, it is how it has been for the past 3 years, in that it's 25% cluster architecture, 15% workloads and scheduling, 20% services and networking, 10% storage, and 30% troubleshooting. So this is the domains and the percentages of those domains that you'll see on the exam. So expect to see a majority of troubleshooting questions, or I shouldn't say a majority, 30%. So a lot of troubleshooting questions versus, only 10% of storage. There's some other links here which are important exam tips. I think will bring you back to the handbook, which we just went over that. But those top 2, the curriculum, what's going to be on the exam, and then the handbook, how to prepare your environment and how to prepare for exam day, are the most important ones to go through or to be aware of. On another GitHub page, so if you go to github.com/chadmcroll/CKA-exercises, you'll see not only the exercises that are a part of those domains according to the CNCF and the exam makers, but there's also important information about how the exam changes. And the exam changes are coming January 15th. They did push back the changes. It was originally November 26th. And they pushed it back to January 15th. So you have a little bit more time to still take the current version of the exam. I will say that the additions that have been made to the exam after January 15th, they are quite significant. So if you are close to being ready to take the exam, I would encourage you to take it before January 15th if you can. But we'll help you along the way no matter what. So just we'll get into the changes, and then I'll tell you how you can learn more about changes to my book, which was mentioned, and also some of the other resources that you can take advantage of. So let's click into this and read more about the exam changes that are going to be happening after January 15th. So notice here, I haven't changed the heading here, so just ignore that. Again, it was pushed back. It's no longer November 25th. It's the 15th of January. So you have a little bit more time. So this means that if you take the exam on January 15th, it will be a different version of the exam. And any future date after that will be a different version. If you take it on January 14th, it will be the old version. January 15th, Just know that the dates are very, I guess, straightforward in that, January 15th, there's a so one other question that comes up a lot is because there's a free retake with this exam. So if you fail the exam on the first try, you have the opportunity to retake the exam for free. If you let's say you take the exam on January 14th, and then you fail it and take advantage of your free retake, you take it on the, let's say, 15th or 16th of January, you will get a different version of the exam. So there's no, I guess, reservations about, taking the exam prior to January 15th and after. And, if it's pretty, to drive this point home, if you take the exam, whether it's a retake or otherwise, on the 15th, you will get a different version of the exam. Okay, I think I think I have explained about that enough. So the official announcement is, put out by the Linux Foundation, and you can read up about, kind of why they're performing these changes and what the reasoning behind it is, and just, what will be changed. So you can read more about that. It's a very short article. You can read it in a matter of minutes. And so this is what we'll go over in a second, but this is just the official announcement. And again, January 15th is the day. CNCF also has a blog that is explaining these in a little bit, I guess, informal terms, if you will, or just further explanation as to why the changes are happening and the evolution of Kubernetes as a platform, and why these decisions were made. So again, they have not changed the November date to January 15th either, but being that Linux Foundation is the one that's hosting the exam, they have the January 15th date on there. It is definitely, most certainly moved to January 15th. So read about that if you want to know a little bit more about why those decisions were made. I've created a side-by-side comparison here, and I think that's important because you're looking at the old version versus the new version. You want to see what's changed, what's being added and removed. So you can again just click on that link like I just did to view the side-by-side comparison. And this just goes through each of those domains and what changes will occur. So before, and let's, for all intents and purposes, let's pretend that November 25th is January 15th. So before January 15th, this is what the curriculum looked like. And again, we're getting this directly from the curriculum from the official, the CNCF curriculum that we looked at initially. So this is just putting them side by side. And you'll see that some of the items have changed. Maybe they're using different verbiage. Maybe they're being more explicit. I did notice, for example, the manage a highly available Kubernetes cluster has been changed to prepare underlying infrastructure for installing a Kubernetes cluster. So this is a little bit more explicit and what you actually need to know, which I like and I appreciate, and I'm sure you will too, being that you certainly want to be as explicit as possible when trying to kind of explain what's going to be on the exam to know better what to expect and how to prepare. And then after November 25th, we noticed that instead of just saying, where is it? So yeah, instead of just using general verbiage on the left-hand side, on the right-hand side, you'll see use Helm and customize to install cluster components, which is very clear. You'll be using Helm and customize on the exam, which is good to know. Also, a big addition to this section of the exam, the cluster architecture, is the understanding CRDs installing and configuring operators. So I have a walkthrough, a lab that you can take for free on the Killer Code environment, which we'll get to in a second, where we'll gain a better understanding of what that means and go through an example scenario of installing CRDs and operators. Moving down to workloads and scheduling, not much has changed here, just a little bit of the verbiage and again, being more explicit, which I appreciate. And so workloads and scheduling, for the most part, is staying the same. Services and networking, this is the biggest change being that its gateway API is going to be used in addition to Ingress controllers. So if everyone's familiar, maybe not, with gateway controllers versus Ingress controllers, gateway API is certainly the future in terms of providing an Ingress route to your cluster from outside. And so the gateway API just provides a lot more advanced routing capabilities on top of Ingress controllers. And so that's why they added that component. We will also go through an example of using the gateway API, and we'll be using a Civo Kubernetes cluster for that, which we'll get to after we go through the CRDs and operators. So stick around and we'll get to doing some hands-on work and getting some practice with these new competencies that they've added to the exam. Scrolling down to the storage section of the exam is staying the same, so that's good. And then troubleshooting is also largely staying the same. A little bit different verbiage there, but as you can see, very helpful for knowing the troubleshooting domain. All right, so again, that URL, if you want to have everything all in one place and just have a better understanding and side-by-side comparison of the old exam versus the new exam, go ahead and head over to my GitHub page, github.com/ChadMCrowell. All right, so without further ado, let's go over to some of the exercises. So I hope everyone is familiar with Killer Coda by now, but if you go to killercoda.com, you will see the certifications up right at the top, right as you first see this page. And so if you go to CKA certification, you'll see a number of exercises, over 100, I believe. Yeah, over 100 kind of scenarios and exercises that you can take for free. Again, this is a great resource to use if you're preparing for the exam, if you're studying. This is an incredible resource just for the fact that you can have access to a Kubernetes cluster on demand within seconds and be able to kind of instantly practice and prepare yourself for the exam, being that the exam is in a very similar format inside the terminal. So you're performing the commands, you're getting muscle memory, you're getting that daily practice, you're actually performing those commands and having that cemented into your mind. All right, so if you scroll down, you'll see my 30 plus scenarios here. One of them we'll go through right now. All right, so we have this at the very top, install a database operator. So this is the part of the exam that's going to be added after January 15th. And this is going to be, as we mentioned before, that section of the exam in the cluster architecture, installation, and configuration, 25% of the exam, which is understanding CRDs, install and configure operators. So let's go ahead and do that. This is very easy because if I click on this, not only do I have access to a cluster, I have the kind of walkthrough on the left-hand side. So this is very helpful for copying and pasting commands. So we can go through this very quickly. And if you're watching this right now, either on the recording or otherwise, you can follow along. So I encourage you to do that if you can. All right, so installing operators. So let me tell you a little bit about operators and what their purpose is inside of Kubernetes. So operators, act as an extension to Kubernetes. And you can, there's two most important kind of operator types, which one is the operator SDK, which is, I believe, a Red Hat project or related to Red Hat in some way. Operator SDK is a mechanism to which you can easily kind of bootstrap, if you will, an operator. Another, I think, far more popular way and possibly a more kind of open source or a more, let's just go with popular way of configuring and bootstrapping an operator, which would be using Kube Builder. So those are the two ways in which you can create operators, and there's two ways to, I guess, think about why we would use an operator. One, using the operator SDK or Kube Builder, you can create your own operators. So this is a functionality that can be used inside of Kubernetes, through the Kubernetes API, and still utilizing the existing resources in your clusters, but also you can add extensibility into your cluster, which means you can create unique resources and utilizing the same kind of controller framework and the same kind of elements of Kubernetes, but you can create, in addition to deployments, stateful sets, services, Ingress, etc., you can create these custom resource definitions, or CRDs as they're called, which can operate in a similar fashion inside your Kubernetes cluster. And so this is really a really good benefit to Kubernetes, in that you can still take advantage of kind of the Kubernetes way, but also on top of that, make it customizable and make things that you don't ordinarily see in your Kubernetes in a vanilla, so to speak, Kubernetes cluster, or things that you want to provide resources for, such as databases, such as a gateway operator, or a Ingress controller, customized Ingress controller, let's say. So these are the types of things that you can add in addition to your core Kubernetes components that will add functionality to your cluster. So going back to what I was saying about kind of the two different ways that you can do it. You can create your own operators, or you can use community operators, which, as the name implies, are created by the community and are going to be used for specific purposes, but again, are open source and provided by a community of developers, and hopefully a large community, to ensure that everything is functioning correctly, or as it should. But the kind of the biggest example, or the most helpful example, I would say, is thinking it in terms of a good example of a community operator is the Postgres operator, or the Prometheus operator is another very popular one. As a matter of fact, if you go to my YouTube page, so youtube.com/cubeskills, you could see I created a video that walks you through how to install the Prometheus and Grafana operator. So check out that video if so. All right. In this example, which we're going to go through in Killer Coda, we're going to install the Postgres operator, and this is provided by the folks at Crunchy Data. So if you want to kind of read more, or read up on this operator, how it's created, etc., you can go to this link, which I'll put right here, commented out, or you can just go to github.com/crunchydata/postgres-operator. And so PGO, the Postgres operator from Crunchy Data. And so this is what we'll be going through in terms of installing an operator. So again, left-hand side is where you can copy and paste commands. And so the first thing that you need to do as a part of this exercise is fork the repo that contains all of the operator examples, which we'll be going through. I've already done that in the background, so I'm going to just export the environment variable, which is going to be my GitHub username. And let me bump up the font a little bit to make sure that you can see what we're typing. Hopefully that's good enough. Let me know if it's not. So once I've created that environment variable, I'll go ahead and clone that repo down. So if I get my present working directory, I'll see I'm now in the Postgres operator examples repo. All right, let's install the PGO operator using the command kubectl apply -k. And we're doing a couple things, or I guess we're learning about a couple things all at once here. We're not only learning how to install the operator, but we're learning how to apply or install something. In this case, a namespace, and then another set of YAML files using customize. So customize, again, I covered this in the exam changes when we did the side-by-side, but the customize is something that will be on the exam in addition to Helm. And customize and Helm are just ways of taking a whole bunch of YAML files and applying them all at once. In the case of Helm, in kind of packaged together inside of a Helm chart. In the case of customize, kind of utilizing customize to easily apply a bunch of YAML files that may be in a directory. So in this case, if we actually change directory, or let's open this namespace file just to see what a customize. Let's just see how simple a customize file, customization file might look like. So customize, install namespace. And so as you can see, this is all that we see. Illegal file name. That's weird. Okay, sorry. So let's actually open the file, customization.yaml. So the -k pertains to everything that's in this directory, which is in this case, the customization.yaml and the namespace.yaml. So each time you do that kubectl apply -k, you must have a customization.yaml file, which in this case is just pertains to certain resources. In this case, the YAML file, which creates the namespace. So this is a very, I guess, as simple as you can get in terms of creating a namespace. We all know that you can create a namespace with the kubectl create ns command. This is another way to do it using customize, and this is as easy as you get. So going back to our original directory here, and just in the kind of root level of the repo, let's go ahead and run those commands to install both the namespace and the operator itself. And again, if you wanted to see what the other customized directory looks like, so customize install default, we could see there's a customization file in here as well. And this is a little bit more lengthy, not just the resources, which pertain to the CRD, the RBAC configuration, so the roles and role bindings, but also the manager, which is the essentially the controller manager for the database operator. And then we have the components as well. So this is a more detailed customization file, which you may see. So I would say the main things to memorize for the exam are going to be the not only the kind, which is a customization. There can be an API resource as well, but there's labels, resources, components. So I would read up on that if you haven't already. And if you're unfamiliar with customize, you can go to the customize GitHub over in Kubernetes SIG's directory, and you can read a little bit more about customize and how to use it and how to install it. It's nice that the Killer Code environment already includes all these tools. So again, a benefit to using this free resource. All right, now that we've installed the components that we need for the Postgres operator from Crunchy Data, so just making sure we're in the right directory there again. So to check on the status of the installation, we can run these two commands. So we have pods that have been created as a part of that customization YAML, right? So we have our pods, in this case, just one. So we have one essentially copy of the database. And then we have the CRDs that have been created as a part of that operator installation. So CRDs, again, are custom resource definitions. And this is defining the different resources that we can create that related to our Postgres database. So Crunchy Bridge clusters, PG admins, PG upgrades, Postgres clusters. And those are the resources that we created that are custom to some of the default resources that we have in Kubernetes. So if I just do kget CRDs, I'll see all of them, and we can see we can add additional ones as we just did. All right, so next step is to actually create the database. So we installed the operator, which allows us kind of the custom resource definitions and the kind of the base level, what we need to install these CRDs on top of it. So now let's go ahead and do that. So we have this, again, this apply command, which is targeting a customization.yaml or a customization.yaml directory. And k apply -k is how we apply all of those YAML files and that are configured under the resources in the customization.yaml. All right, so now we'll see if we get the Postgres clusters. Postgres clusters is one of those CRDs that we created. We'll see we have one Postgres cluster, Postgres database cluster named Hippo. And we can also describe this Hippo database cluster, and we'll see certain events which may or may not be important for whether the database was created successfully. And in this case, it was. So as a part of creating the Postgres cluster, the Postgres operator creates a Postgres SQL user account. This is credentials for accessing the SQL server or the Postgres server via SQL. And so we can see that those accounts that have been created. And the one that we're kind of talking about here in terms of the user is the hippo-pg user-rhino. So that's the user that we can use to access the Postgres cluster. To make sure that we can access the cluster, and perhaps you've heard about this before, but we can perform a port forwarding command to make sure that the service that's available as a over the IP address of the pod. So we can see the pods here. And if we do O wide, we can see the IP addresses. And then if we get the services as well, we'll see that there are services that are created that route to or have endpoints for those particular pods. And so we'll open up a new tab up in the killer code environment. And we'll just do that port forwarding so that we can reach those underlying pods through that port forward. So the port forward command is right here. So we'll go ahead and copy this. And the default port is 5432. And so we'll go ahead and expose port 5432 locally so that we can access the Postgres database just over localhost. All right, so we want to establish a connection to our Postgres cluster, and so we can follow these commands to extract the username, password, and database from those secrets that we looked at earlier. So from this command, these secrets contain those things, so the username, password, and database. So we'll just do one at a time here and export these environment variable and store them in an environment variable. The first one will get the user secret name. And we happen to know that name because we looked at the secret. So we'll just use plain text there. And then we will get the Postgres password by extracting the secrets and getting the data out of the password field and then base64 decoding. Because as we know in Kubernetes, the secrets are stored base64 encoded. So we need to do that. And then the PG user, same thing. We're extracting that secret and getting the data.user field, and then base64 encoding that, decoding that, I should say. And then we are finally going to get the PG database, so the name of the database, using the same kind of mechanism. With that, we can go ahead and just connect to our host over localhost because we're doing that port forward, and we'll run the psql command. And so we can do a lot of things here, but just for the sake of making some kind of change, we'll add a schema. So a schema establishes a namespace within a database, just a way that you can kind of isolate different database objects. So we'll create schema Rhino, authorization Rhino. So we'll do, that's the user from up above here, the PG user. So we'll create that schema for using that Rhino user for the Rhino user. And so now that we've done that, we've made some sort of change inside of the Postgres database. And so we have, some kind of stateful data, if you will, to work with here as we go through the next step. And so the next step is to scale the database. And so this, may or may not be a question on the exam. So how do you scale a Postgres cluster? Right now, we see from our git pods command, we see that we have just one copy of our database and the primary copy. And how do we create more copies? How do we create read-only copies so that when database failure occurs, we can have a number of replicas taking over? So how we do that is we can get first we can get the Postgres clusters and output the YAML for that particular Postgres cluster as it's defined in the custom resource definition. And if we scroll up here, what we're looking for is the replicas. And right here under instances, we'll see the replicas right now are set to 1. So what we can do is we can change that to either 2 or maybe even 3. Let's do 3 in this case. So if we do kubectl edit Postgres clusters hippo, because that's the only cluster that we're working with here, and then we'll just search for replicas again. And this is the same YAML that we were just looking at a second ago, but just looking at it from editing the resource versus just viewing the resource. So we'll change that from 1 to 3. If you can see that, just change the replicas from 1 to 3 under the instances category there, or the instances, I guess it would be called a dictionary. And then we'll go ahead and save and quit. What that does is it edits the Postgres cluster, the Hippo Postgres cluster, in place, and allows us to scale up our database. So as we see, we can run get pods again, and we'll see we have now 1, 2, 3, each with a different 4-character string here in between the instance 1 and the 0 at the end. And as we see here, it has an init container, and we can watch those pods come up as the containers within start to come to a running status. And so when we see 4 out of 4, that means that our Postgres database is in fact scaled and ready. Another thing you might be asking is, how do we tell which one is the leader? As we know with databases and SQL databases in particular, there is one copy of that database that is the just responsible for reads and writes. So it is the primary, and then the other replicas should be just reading the data and synchronizing the data from the primary in order to have that consistent data. So how do we see which one is which? If we scroll down on the left-hand side here, we can see how to do that. And yep, so we can get pods again. And in addition to getting the pods, we can show labels. Okay, maybe I was getting ahead of myself a little bit, but this is on the next page, so we can copy this command here and grep out for roles, and we'll see. This is a little bit hard to see, but if you see the pod name is right here. So this one's a replica, and then the other pod name is right here. This one is labeled role equals master, which is the primary. And then the third one is here, Q89D, and that role is a replica as well. So this is how you tell which one is the primary and which ones are the replicas, or the read-only copies of the database. All right, so that's good, because we don't want to have, I guess, deduplicated data. All right, so now let's simulate a database failure. So what happens if we delete one of those pods and simulate a failure? How do we do that, and also how do we ensure that our cluster comes back, with the appropriate number of pods and it replicates the data and all that stuff? So let's go through that now. So now that we know which one is the primary, the one responsible for reads and writes, and again, we'll bring that up. And so it's this one. Let's just copy that name so we have it. So this is the primary. And so let's see, just for fun, let's just see what happens when we delete that pod. So in the Postgres operator namespace, delete pod, or PO for short, and then the pod name. Let's delete the primary and see what happens. Let's get the pods and watch with the -W. And here we go. So we see a new one coming up. So we deleted the PKKX. So PKX is down, and now it's coming. Another one's coming back up. It looks like 3 out of 4. And then let's see if we take that -W off, we'll see 4 out of 4. So it has the same name. So PKKX, but the containers within that pod seem to have recovered, and now they're back in a running state, which is good. All right, so that seemed to recover nicely. Let's see from inside the database what that looks like and how we can check to see if replication is still occurring and that our database is still healthy. All right, hopefully we're doing okay on time because I still haven't looked at the. I'm still not sure how we're doing on time here, but hopefully we have enough time. Hopefully, hopefully everyone's still there. Hopefully, I'm not talking to myself.
Yes, Chad, go ahead. I think we should definitely complete some of the exercises before you let you off, so we can take extra time. No worries.
Okay, great. Just making sure. All right, so if y'all want to stick around, I think this is being recorded, so I think just wanted to be respectful of people's time. All right, so how do we check to see if replication is still happening and that our cluster is still, our Postgres cluster is still operational and still healthy? All right, another way that we can, instead of getting a connection to our database again, and we'll get to that in a second, another way we can do that is we can describe the Hippo Postgres cluster, and we can see the events. If there were any problems, there would be more information about the events there. So that's one way you can do it. That's outside of the database or from the Kubernetes side. And then also just wanted to mention that we can get the logs from that pod as well. And right here we're just specifying the labels for the pods. These labels are applied to all pods that have to do with that operator. So we're looking at the operator pods and seeing if we're seeing any errors in here. So perhaps this is a kind of a troubleshooting part of the exam in that there may be a problem that you need to address in here by either viewing the logs or describing the cluster to get the events. Two very useful techniques. All right, so again, how we can get a connection to the database again is psql-h localhost. And server closed connection unexpectedly. That's probably because we lost our port forwarding. Yep, so let's do that again. So now that we're port forwarding again, let's try that again. Boom. And we're in. So one thing that we could do is select PG is in recovery, open and close parentheses, and then we'll see T. So the one that we are connected to right now indicates that the node is a replica. So this, connecting over localhost is again, you'll get one of the three in terms of what that service is providing when we port forward. But again, this is what we get. We could also exec into one of the pods, and again, if we list the pods, we can just choose one of these to exec into. So let me clear the screen. So get pods, kexec it in the Postgres operator namespace, and then the name of the pod. So we'll just choose one of these. And then we will get a Postgres CLI to that inside of that pod. So psql-u Postgres, and then the database name is Postgres. And so now we can do select pg underscore last wall replay lsn. And we could see that there is data in there. So that means that we are good to go. So this shows the replication status. And so being that we have replication occurring, we're seeing one row of data in that column. All right, so that's it for installing a database operator. So hopefully that gets you good practice for the exam in regards to the that new exam criteria in which you will be responsible for knowing or understanding, I should say, understanding CRDs, installing and configuring operators. So that's a little bit about working with operators. All right. Next one that I said that I was going to cover was the Gateway API. And so I do have an exercise that we can go through together on that. So unfortunately, Killer Coda doesn't allow for using Ingress controllers or gateway controllers, just because it's kind of a lockdown environment, and we can use the node port type services, but we can't use any additional any additional load balancers or Ingress controllers there. So I'm going to do this in my favorite cloud provider, which is Civo Cloud. So let's go to civo.com and spin up a cluster. It's super fast, so I encourage you to check it out if you haven't already. If you have never heard of Civo or have never tried it, you can get $250 to play with when you sign up with your credit card. All right, so let's go to Kubernetes clusters, and I have a few already, but just to create a cluster, we do create cluster. Let's call this test 3, because I have lots of test clusters, as you can imagine. Let's just do 2 nodes, medium, and we can even do a specific network or just choose the defaults. You don't have to do this. I can choose my version of Kubernetes, 1.30.5, let's say. We can choose the CNI. We'll choose Flannel, cluster type K3s or Talos. We'll choose K3s. And then in the architecture tab, which is the marketplace for a lot of these things, instead of the node port, we'll choose the traffic load balancer. And then we'll click on create cluster. And so creating a cluster is super easy. Just go through those clicks, those few clicks, and then you'll get a cluster in under 3 minutes. While that's building, since I don't want to sit here and go through this for 3 minutes, even though that is a pretty amazing time to spin up a Kubernetes cluster and get access to a Kubernetes cluster, let's just speed things up for the sake of time. And so let's go ahead and get connected to our test 2 cluster, which I created prior to this call. All right, so now I'll just download my kubeconfig. And let's bump this up a little bit so you can see. All right, so hopefully that's big enough. All right, so I'll export my kubeconfig variable and just change where my kubeconfig is located. So kget nodes, and I should see K3 test 2. All right, brand new cluster, by the way. So I didn't install anything yet. So part of the benefit of using Civo in this case, or using a managed cluster, is that the control plane is managed for you, so you don't have to spin up your own control plane and manage it. This is the kind of advantage that we're taking advantage of here. But also what this provides is just an easy way to control a cluster and access to a cluster, install the things that we need to install related to our API gateway and the underlying resources that are required. So let's go ahead and start by installing Contour. So Contour is a one of many gateway controllers that you can use with your Kubernetes cluster. Some other common ones are the Istio gateway. Another one is the Nginx gateway. And those provide an entryway into your cluster from outside. So yeah, let's go ahead and install this using Helm. We used Customize before. Now we'll use Helm to install this contour gateway ingress controller or gateway controller that's going to be used with the gateway API. All right, so I will add my Helm repo. I've already added this prior to this call, so it's already set. But if you are adding this for the first time, you'll see this is going to be added to your Helm repos. And then if I do a Helm repo update, that just makes sure that we have the current version of all the Helm charts. And so we're using, again, the charts at bitnami.com. And in particular, we're going to now install the contour gateway controller. So we'll do a Helm install contour, and then we'll specify that Helm chart in the Bitnami Helm repo, bitnami/contour. We'll put that in the namespace project contour. And then if that namespace doesn't exist, we'll create that namespace, and then we'll set the gateway controller to true. So we'll enable gateway controller along with this installation here. So it takes a couple seconds, but just hang in there. Once this is done, we can check on the pods to ensure that Contour and the Envoy pods, which Envoy is used with Contour to provide the routing into the cluster from outside. And while we're waiting for that, let's just I'll tell you a little bit more about Contour. Contour API. So here we go. Projectcontour.io if you want to read up on the documentation for Contour. And Contour provides ingress controller as well as a gateway controller. But this is kind of the getting started guide that you can view and do this on your own if you're wanting to use Contour as opposed to Nginx or the Istio. All right, now that that's installed, let's go ahead and check on our pods and see that those are all up and running. And they are. So that's great. So again, Contour, we have our Contour controller and then our two Envoy proxies that are going to be handling the traffic incoming to our Kubernetes cluster. All right, so now we'll deploy a gateway resource. And in order to do that, we need to install some CRDs. So we'll do apply-k. Again, if you remember from our last example, this means that these are the customized files that are in this directory, but we're just going to specify the github.com/Kubernetes gateway API repo, and then the customization.yaml is inside of there. And so again, this allows us to use custom resources within our Kubernetes cluster that haven't been created yet, and they're listing them as we speak. So these are all the things that I could create as a result of installing the gateway API into my Kubernetes cluster. So lots of options for how to route traffic. Now that we have that, we can create a gateway resource. So we'll just bring up an example of a gateway resource that we might create as a part of the gateway API. And this is a pretty simple one, which just lists the gateway class name, which is Contour, which is what we just installed using Helm, and then listening on port 80 over the HTTP protocol. So now that we have that gateway resource created, or the YAML for that resource created, we can apply-f gateway.yaml and make sure that our gateway has been created. So we can do get gateway and that's in the project contour namespace. And we don't have an address yet because we haven't created any routes. So let's clear the screen and add our, first we'll add our application. So let's see, we will add our application. This is just going to be a simple kind of, it could be an Nginx server, it could be anything. This is just something that's going to be serving traffic that's going to resemble our application that we're building here. So I will name this echo server.yaml. And we're just creating a deployment and service at the same time. And we're just using the image EALEN, alien, / echo-server. And we're also creating a service that's called echo-server. And we're exposing that service on over port 80. So pretty simple deployment here. So we'll go ahead and apply echo server.yaml. And we'll change the namespace at the top there to have a colon. All right. So now that we have a deployment, so kget deploy, kget service, we have a deployment and a service. Echo-server is the name of this service. Now we can create an HTTP route to that service. So we'll create HTTP route.yaml. And this is pretty simple as well. It's just creating a route where it's referencing the parent, which in this case is the contour gateway or the gateway controller. And then has rules, much like you would in an Ingress resource, if you're familiar with Ingress resources in Kubernetes, with a path prefix of basically everything, or at the root of the path, routing to the backend reference, which is the echo server, which is the name of our service. And if you remember, the service was exposed on port 80. So save and quit. And now we can apply the HTTP route with a kubectl apply. And now if we get HTTP route, we'll see we have a route to our service. And so let's see. So next step is to test that all of this is working. And so let's see. We have external IP for our service now. And so we're using the load balancer that was created with our Civo Kubernetes cluster. And that load balancer is 212.2.240.57. And so we should be able to curl this and get a response back. Let's cross our fingers here because I'm not sure if this will work. Okay, sometimes it takes a while to kind of establish those routes. But that's basically it. What I wanted to show you with that exam objective. Again, that's for the using the Gateway API to manage Ingress traffic. So just to review, we created a Helm ls Helm repo list. So we installed the repo, or we added our repo. We installed the contour Helm chart. We created the gateway. So kget gateway. We created the application, so deploy and service. And then we created the HTTP route. So those are all the ingredients that you need to replicate this at home. And if you want those instructions, please reach out to me and I will provide those to you. So happy to show you a little bit about how to use the Gateway API to manage Ingress traffic. And that's all that I had for you. So thank you.
Awesome, Chad. I really appreciate the exercises as well. We know the exam is really new and people looking forward to what we can expect from this exam to have. So I hope they have a very good coverage today in this exam as well. So thank you very much. I really like all the exercises, especially this the CRD one. I think it's really depict we how one can expect from the exam as well, because CRD is a bigger portion for the exam as well. And I know like the portion is actually duplicated or actually removed from the exam is because of the etcd backup and restoring. And we know everybody is using Kubernetes at the cloud, and you're the part of the team Civo cloud as well. So people are using Kubernetes in the cloud, so don't need to back up these kind of stuff. But CRD is a major portion. So I have so many questions from our community as well, like how we can expect from CRD angle as well. So hopefully in this YouTube channel there are some exercises Chad have that walk you through what you can expect as well. One question, Chad, and then we wait few more questions in the audience. I will see and check. If let's say the CRD portion is part of the exam, so do we expect to see, because in the Kubernetes you have some sort of anatomy of the object. So when you deploy something in the CRD, so do we expect the troubleshooting section also includes CRDs, and then you fix that up and then make sure everything up and running? Or these are those separate things we can expect in going forward?
So the exam says, understand CRDs, install and configure operators. So I would not expect there to be much troubleshooting related to CRDs. So install and configure, and that's it.
Awesome. Great. And they have some good appreciation notes from you is for you as well. Faraz Singh, thanks for hosting this informative session, taking time for us. I have been following your work and book for a while. Enjoy the session walk through with the playground. Thanks Faraz, and thanks everyone for staying so
Thank
long
you.
with us on this YouTube channel as well. So before we wrap up for the next few steps, so Chad, any things like you have already been thinking or planning for the 2025 for the CK exam, because we're really looking forward to what the newer announcement coming from the CNCF and Linux Foundation, considering for the next few weeks as well. And also on some suggestion, because I have so many questions from our community. Do I actually schedule an exam before the update or after the update as well? So what's your final take on these final two questions?
Yeah. So what I covered today is on the January 15th version of the exam. So if you are taking the exam on or after January 15th, I think this would be helpful to review this video that we just went, and those killer code exercises especially. I would encourage folks to take the exam as it is right now. The only thing that's being removed from the exam is backing up and restoring SCD, which is a good good portion or a good section of the exam that is being removed as of January 15th. But it's I think a lot easier. Maybe this is just me, but I think it's a lot easier than having to learn CRDs, operators, and API gateway. So I would encourage folks to, if you can, take the exam before January 15th, just because, in my opinion, this current version is the easier of the two.
Yes, absolutely, 100%. I think definitely, because we know the section is sometime you need to reevaluate yourself for the exam after taking in 2025, even though before the 15th you need to reevaluate yourself as well. So moving on, the ZCD part is going away, and then we stick to the CRD, Helm, Customize, and Gateway API. I think these are very neat changes for the exam, because I've seen and we both part of the CNC ambassadorship. We've seen a lot of the tooling is around gateway API, because every Ingress controller is now supporting it. And Ingress, by design, has some flaws in it. So enterprises and the companies going forward to implementing gateway API, and they want to test your knowledge. Are you able to equip with the skills that can translate us to the business domain as well? So that's very handy, these newer changes as well. So I encourage, I think mostly people are listening to us, and hopefully somebody watching from this, watching this YouTube on this workshop and after January 15, because that's where you need some exercise file as well. So I think hope some of the course content covered today will be really suitable for the exam need as well. But thank you very much, Chad, for your 76 minutes of non-stop talking and covering the exam. That's really appreciated. And I think this will be another our very shiny workshop in the near future as well. And Umair is saying, when we expect the updates in your book, acing the certified Kubernetes exam? So that's a good question.
Yeah, we're working on a new version of the book, the Acing the CKA book, and it should be out hopefully by January 15th, if not by the end of January. So, yep, look for a new version, the second edition of Acing the CKA.
Oh, that's great. Thank you very much for sharing all these details. So before anybody will let off, because we have so many exercises we can share with you. So first thing first, you need to go through in this URL to see what expecting changes are, number one. Then you have a Git repo. I think somebody from our community wrote this up considering for the newest changes for the exam as well. Thanks, folks, for doing this. Another, we have the book. That's my favorite one from the ACA, acing the CK exam, that Chad wrote, which I had a very good coverage of the book. And we did two other workshops. If you're considering for the other part of the exam, what they are, these are covered on two different places in the different URL on this YouTube channel. This is part 2. This is part 1. And also, Chad actually added CKA changes to his repository as well. So you can actually go and see what changes are in there with a very neat guide. And then we have Helm for Package Manager. So there's a URL for you. Then we actually covered a very good detail of Killer Coda exercise in the Chad wrote on the database operator. You can replicate now as you anytime you want. Then the gateway example will be we explore on the Civo Cloud, which is the fastest way to spin up Kubernetes cluster with ultra high speed. So that's where you can actually go into the Civo Cloud as well. And I think we've used Project Contour for the gateway APIs and all these kind of stuff. And if you want to see or blogs or video tutorial or anything you need to wish for the part of the exam, so we have this repository where you can click on the links and then navigate you the best resources on the internet, providing the good resources for some module in the CK exam as well. So hope we have a lot of coverage for you. So this means you will be overwhelmed in the near future with a lot of the learning as well. But that's a good thing. You need to be learning all right as well. So thanks everyone for listening and joining us to our exam as well. And hope you actually like the conversation, and we will look forward to see what the expected comments in the YouTube regarding to the CK exam, and Chad and I will be try to answer those as well. Have a wonderful day, everyone, and looking forward to your feedback for this live stream. Bye-bye.
Thanks, everyone. Bye-bye.